Hi everyone, Professor Bob Young. Welcome to another exciting instructional video for college algebra. And in this episode, we're going to work on what's called the rectangular coordinate system. And we're going to use a formula in that system called the distance formula. So the rectangular coordinate system was created in the late 17th century, early 18th century by the Frenchman René Descartes. They didn't have any way to map things back in those days. So when Descartes started out, he said, well, we've got to get some organization going here. So he talked about what was called ordered pairs. And these consist of two coordinates written inside parentheses. And of course, the order is very important. Now, most of us, with our experience, know that ordered pairs are always x first and y second, just like in the alphabet. And the rectangular coordinate system consists of a horizontal or x-axis along with a vertical or y-axis, which are really just a couple of number lines when you think about it. And on x, if you go right, that's a positive direction. If you go left, it's a negative direction. On y, if you go up, it's a positive direction. And if you go down, it's a negative direction. And the ordered pair that everyone always starts with is called the origin. And that is the ordered pair 0, 0, where both x and y are 0. So when you start plotting points, that's where you always start from. Now notice these two axes, if you want to plural that, form what's called four quadrants, or subdivides four quadrants. Quadrant 1, 2, 3, and 4. So in quadrant 1, wherever you plot a point, x will always be positive and y will always be positive. So let's just take an ordered pair and plot it here. Let's take the ordered pair 2, 3, and we'll put it right there. And we'll go ahead and label that point, x first, y second. In the second quadrant, x will always be negative no matter where you go, and y will be positive. So let's take a point in quadrant 2. Let's take negative 1 1/2 and 1.2. Yes, you can use fractions, ladies and gentlemen, and you can use decimals in this rectangular coordinate system. In quadrant 3, that's the negative quadrant. Both x and y are negative. Maybe it's just not a happy place. So starting from the origin, I'll take an ordered pair here. How about negative pi, negative 1? Now we know pi is about 3.14. So I'm going to go ahead and say I just plotted the point negative pi on x and negative 1 on y. Close enough for government work anyway. So all points in quadrant 3 will be negative. All right, in quadrant 4, last but not least, x will be positive, y will be negative. And if we take a point in quadrant 3, let's take 1, negative 2, and plot them and so forth. Now, what if someone gives you this point here? Let me go ahead and take green. We'll play with some colors here. What if someone gives you the point 5, 0, and says plot that? Sometimes students go the wrong direction here, but if you remember, ordered pairs always are x first, y second, then 5, 0 will be over here on the x-axis. Similarly, you might have someone say, well, how about the point 0, 3, and that would be, of course, on the y-axis. So just be careful, always going x first and y second. So that's a little review of the rectangular coordinate system. It led to maps being created. It led to compasses, north, south, east, west, and now think about our GPS systems. I mean, it all led to now you can see latitude, longitude lines and satellites from space, and who knew what it would grow into, this simple mapping technique here. Now, not only can you just write things when you use the rectangular system in terms of x and y, Sometimes you business people out there, you may get charts and stuff like this. It says use the table to write ordered pairs to express the relationship between each type of entertainment and the amount of money spent on it. So they may even call the types of entertainment here, and let's go to a pretty blue on this one. We can call this whole column X and the amount spent Y, or whatever you want to do on that one. Okay, so let's look at a few examples here. It says for this problem, go ahead and write an ordered pair using DVD rental sales. So if you look at the chart, DVD rental sales here would be the second row, X, and the amount spent on that would be Y. So look how they wrote this ordered pair. You know, they wrote it even using words instead of just variables. And one more, movie tickets. It says you can go ahead and use the last row. So notice the ordered pair they wrote there, movie tickets are $30, and this is how things are used out in the real world. It's not always just about mapping and so forth. Which brings us to our distance formula that you will have a problem with on the test. And the distance formula will find the distance between any two given points, and there is the formula for it that you must memorize. It's the giant square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we're going to go ahead here, and we're going to take a few points, and we are going to use this new formula in order to calculate the distance. So let's take a point in the fourth quadrant. I'm going to take 6, -2 here, and I'll stay with the pretty blue, and I'll just plot that point. And I'm going to take a point in the first quadrant. Let's go for, let's say 6. And what I'm going to do is just go ahead and join them with a line here. So let's just keep it real pretty blue here. And what the distance formula allows us to find is the actual distance between any points in the rectangular coordinate system. All right, so let's go ahead here and we'll put these points somewhere. So I'll put 6, here, let's fix that. There's 6, that's a bad 6, -2, and 4, 6. And we'll come down here and we'll write the formula below the graph here. So D will equal the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if you practice this enough, you'll never miss one of these on the test. Now, one other thing I tell students, go back up top. On your points, label them. The first point I'm going to call x1, y1. Guess what I'm going to call the second point? x2, y2. Because every point has an x and a y. Get the point? Guess what I would call it if I had a third point? x3, y3. Yes, I think y'all have it. But now all we have to do is just go ahead. It's like the Glade plug-in commercial now. And I'll go to black down here. And we will plug it in. So the distance will equal the square root of x2 minus x1 up top would be 4 minus 6 quantity squared. So the only thing you can do is plug something in wrong or not do some arithmetic right under here. Plus y2 minus y1 would be 6 minus -2. Oh, and I can see those sign errors happening on this already. So this will give us, and I'll come around up here, the square root of -2 squared under the radical plus 6 minus -2, 8 squared under the radical. Oh, watch those signs. Will give us the square root of 4 plus 8 squared is 64. So we get the square root of 68 as the distance. Or is it? Now, wait a minute. I think the square root of 68 will simplify, because I think there's a perfect square number that goes into 68. I think 4 goes into 68 17 times, so we could break that up into the square root of 4 times 17, which would simplify into a distance of 2 times the square root of 17. Okay, so be very careful and make sure you simplify the radicals here. Now, where does this formula, this long, nasty-looking formula, come from, this distance formula? Well, I'm going to go ahead and we'll take some other pretty colors here. I haven't used orange in a lot of the episodes, and I'm going to, from this one point up here that we drew, I'm going to go ahead and put a point in orange here, and I'm going to draw me I'm going to try to make this a straighter line here. Sometimes my lines aren't as straight as I want them. All right, I'm going to call this line here in orange a certain distance, and I'm going to take a cool green, and I'm going to come across this bottom part with a cool green color. Now I'm going to go back to I'm just going to stay with the cool green. Now, believe it or not, they called this distance in green x2 minus x1. Okay, so I'm going to put x2 minus x1. That would be the difference of the x's down there on the bottom. Here's where this formula comes from. The orange, guess what they called it? They called the orange distance y2 minus y1. So really the distance formula comes from the Pythagorean theorem for right triangles. Do y'all see, if I take, and I'll go back to my black marker now, or red here, if I take this squared plus this squared, I will get this distance squared. And then taking the square root gives us the coveted distance formula. It comes from the Pythagorean theorem that we talked about in chapter 1 of right triangles. And you thought we were all done with it. So you will have one of these distance formulas on the test, so know it and know it well. All right, let's try one more example with the distance formula. I just threw a few other points in here. And let's again, whenever you're given points here, let's go ahead and label them. And I'm just looking at how this graphic labeled them here. And it doesn't really matter which one you call x1, y1, or x2, y2. So I think what they did is they called this Q point x1, y1, and this P point x2, y2, just to be different. See? So it doesn't matter as long as you're consistent which one you call which. And then we'll write the formula here. Oh, they didn't write the formula in the graphic. How bad of them is that? So the distance D, now they call it D between P and Q there, is x2 minus x1 quantity squared minus y2 minus, or plus y2 minus y1 quantity squared. There's another way you can mess it up, mess up the formula. All right, so let's go ahead and we'll plug in here, and you can see that, great Scott, they didn't do it that way, did they? They went ahead and they called that top point x1, y1, and the bottom x2, y2. But I wonder if we just did it this way, and sometimes I do things just to be quirky. Let's see if we just did it the way I showed you, if it would still come out the same. It would be negative 8 if I call that one x2 minus 3 squared plus 4 minus negative 2 squared will give us the square root of negative 11 squared plus, watch those signs again, 6 squared. And notice I'm going to get, no matter which one you call x1, y1, and which one you call x2, y2, when you square things and subtract them, you're going to end up with what they did down here. So the distance between those 2 points would be the square root of 157. Now the square root of 157 doesn't simplify. So you could also, what sometimes the textbook will have you do is just go ahead and write that number. So you can take your calculator and you can hit square root on there. So the square root of 157 is approximately 12.5. If you wanted to get a number out of that, that made a little bit more sense there. Okay. Now, here's the acid test for showing if something's a right triangle, and that is if it passes the Pythagorean theorem. If the sides A, B, and C of a triangle satisfy our friend A squared plus B squared equals C squared, then we can prove things are right triangles. So in the next example, they are going to give you 3 points and ask you, are these 3 points vertices of a right triangle? And the only way to find if that's true or false is, guess what? Get the distance between all 3 points. So in other words, we want to get the distance of M and N. So you may want to go ahead and pause the video here and see if you can get these 3 distances using the distance formula. You need to get the distance between the points N and Q, and then you would have to get the distance of, what's the other pair? M and Q. Put commas in here. Now, then you have to compare the distances. So the only way, I mean, you could try to plot those points and connect the dots, but you may or may not have a right angle in there. I mean, only this acid test of the a squared plus b squared equals c squared will check it. So let's go ahead and run through this. So if you did this on your own, did you get the distance between M and N as the square root of 200? Which, I don't even think that they simplified into the square root of 100 times 2, which would simplify into 10 times the square root of 2. They didn't even simplify the square root of 200. Try the next two. Did you get the distance between M and Q as the square root of 400, plugging in things correctly, which is 20? Now that one came out nice. I like when square roots come out nice, and it's got the picture up there. Did you get the distance between N and Q as the square root of 200, which again, they should have said is 10 times the square root of 2. Bad authors here. Now they just left it 200 to show you that if you took a squared plus b squared, the square root of 200 squared, remember from our radical section, when you square a square root, it comes out nice, plus the square root of 200 squared. So if you take the 2 smaller sides and square it, and it gives you the long side, you have shown that this is a right triangle. And one last thing you can do with the distance formula is you can tell if points are what's called collinear. All right, and notice they spelled it on the graphic 2 different ways there, which is kind of strange. Where do I get these notes from and stuff? So anyway, we can tell 3 points are collinear, or if they lie on a straight line, using a similar procedure. So 3 points are collinear, and I think that's 2 L's here. So let's take the pretty blue here. Gosh, young, you are just a stickler, and we will fix this graphic. Okay, 2 points are collinear if the sum of the distances between 2 pairs of points is equal to the distance between the remaining pair of points. Now, I know what y'all are saying. What the heck are you talking about, young? All right, let's look at something here. Are these 3 points collinear? Now, again, this is just a great example of, getting the distance here. So what I would like you to do, if you want to pause again and practice this distance formula, is to get the distance between the first 2, the last 2, and the end 2, and see what you get. Now, of course, you're kind of cheating on this one because the first 2 you've already seen the distance is 3 times the square root of 10. All right, the distance between the last 2, if you use the formula correctly, I don't know if you paused or not, or are you cheating, is 2 times the square root of 10. And the end 2 is 5 times the square root of 10. Now notice, because 2 of them add up to give you a third, you can test and see if points are collinear using this. So these 3 points are indeed collinear. They would lie on the same line. So signing off, Bob Young. Hope you're enjoying the rectangular system and the distance formula.